The second grant we are pleased to announce tonight is for Dr. Alain Stintzi, Professor and Interim Director of the School of Pharmaceutical Sciences at the Faculty of Medicine, University of Ottawa. His current research combines techniques from various scientific fields, including gut microbiology, genetics, functional genomics, medicine, chemistry, biochemistry, and bioinformatics, to study the role of gut microbiome in human diseases. We are pleased to welcome Dr. Stintzi's colleague, Dr. James Butcher, who is a research associate at the University of Ottawa, whose research interests focus on human microbe interactions, and in particular, the microbiota's role in pediatric inflammatory bowel disease and other chronic diseases. He's here to present their upcoming research in this area. Thank you so much for joining us, Dr. Butcher.
Thank you very much for having me. First, we would, myself, Dr. Stintzi, the other co-applicants on this grant, Dr. Bernard Jasmin, Dr. Hans Lockmother, would really like to thank the committee for selecting us and giving us the opportunity to move forward with our research. Without the patient input and these resources, there's a lot of research that would just never get done. So we're really grateful for that. So I'll give a brief talk once we connect. So you can see my screen correctly?
Yes, thank you.
Okay, great. So I'm going to give a little bit of a background because my talk's going to be quite different from what we've talked about in the past today. So really, our lab focuses primarily on the human microbiome. So the microbiome is a set of different communities that exist all over our body, in our mouth or on our skin, and then there's a massive amount of microbes in our gut. And these microbes are involved in doing really essential functions for us. They help us with nutritional digestion, they help us regulate our immune system, and they also protect us from pathogens. So it's not surprising that the gut microbiome has been implicated in a very wide variety of diseases, such as inflammatory bowel disease, liver disease, diabetes, obesity, brain disorders, and various different cancers. But one thing that's been studied, but not studied to the extent that we think it should have been, is the microbiome's role in muscle health. So muscle is one of the largest organs of our body, and there are a lot of ways that the microbiome could influence muscle. And there are very intriguing studies in mouse models that have shown that the microbiome can have a direct impact on muscle health, especially in elite athletes. So we've done some preliminary studies, and our initial results suggest that there is something very different about the microbiome in dystrophic mouse models. And what we think is happening is that the microbiome in healthy patients is producing a lot of beneficial metabolites that's helping to promote muscle health and promote healthy conditions overall, and not producing a lot of harmful metabolites. And what we think is happening in a dystrophic condition is that we have a reduction in these beneficial metabolites and an increase in these harmful metabolites. One of the reasons why I keep saying that we think is that for some reason, there's never been a study looking at the microbiome in Duchenne muscular dystrophy patients, which is really a gap that we feel is really missing in the field. And that's one of the goals of our project, which I'll just go through with very quickly. So our goal is to first characterize the microbiome in mouse models and determine what is it about the microbiome that is potentially affecting muscle health. So simply asking the question, so what are the microbial metabolites that we need to either increase or decrease to improve muscle health? Next, we have a lot of experience in dietary compounds and how diet can potentially change our microbiome to improve it and make metabolites we need for health. So we want to, once we know what metabolites we need to increase, we want to look for dietary compounds that will allow us to increase these microbial metabolites. and specifically targeting microbial metabolites that will improve muscle health. Lastly, and this is one of the most exciting parts of our project, we really want to characterize the microbiomes from DMD patients from across the disease spectrum, early onset disease, late onset disease, undergoing different ambulatory conditions, different medical treatments, so that we can determine what really is different in these microbiomes and how can we shift these metabolites, metabolite production to increase human health, and really demonstrate that whatever we've identified, can we shift the microbiome using the dietary components that we've identified? And can we actually improve these patient profiles in the hopes of being able to improve patient outcomes by a dietary therapeutic that would be easily able to be administered, because most dietary foodstuffs do not require any additional regulatory oversight, and it would be something that would be allowed to be implemented at the same time as existing therapies. Thank you again very much for giving me the opportunity to present.
Thank you so much for all that information. I really appreciate it. And with that, that completes our grant announcement. Thank you everyone for these exciting updates and for the information about this year's new grants.